Welcome to Building Applications with FireDAC.
Hello, my name is Cary Jensen, and this is Building Applications with FireDAC. For quality purposes, all lines except the presenter are muted. It's okay to ask questions, just use the Q&A panel on the right. This webinar is being recorded for future playback. Here's a little bit of information about me. I'm Chief Technology Officer at Jensen Data Systems. I've got more than 30 years of experience as a developer, consultant, trainer, and mentor. I'm the author of more than 25 books on software, including my latest book, Delphi in Depth, FireDAC. I specialize in database development, application architecture, and component development. I'm an MVP and a Spirit of Delphi recipient. I have a PhD in engineering psychology from Rice University in Houston, Texas. And on this slide, you can see the various ways you can contact me. All of the examples in this presentation were first introduced in my book, Delphi in Depth, FireDAC. I'm including all of the book's examples in the code download for this presentation. However, I'm only going to be working with a few of the examples from the book. There's about 40 different projects that the book describes, and I'm going to talk about seven of them or so. The URL for the code download can be found on the final slide of this presentation. And I should mention that the book explains all of the code examples that are covered there. If you're interested in buying a hard copy or PDF version of this book, go to www.jensendatasystems.com/FireDAC book for links. Here are the topics I'm going to cover today. I'm going to begin with a review of the RAD Studio data access mechanism and the TDataSet interface specifically. I'm then going to discuss FireDAC in particular and outline all of its capabilities. Then I'll continue with a discussion of 7 elements of FireDAC. I'm going to talk about FireDAC and configuration. Next, I'll cover FireDAC indexes. I'll talk about the basic navigation and editing of data using FireDAC. And then I'll discuss the SQL preprocessor, array DML, cached updates, and local SQL. RAD Studio and the TDataSet interface. The TDataSet interface has been around since Delphi was originally shipped, and in the first version of Delphi, that was supported by the Borland database engine. And in the Borland database engine, you had the concept of a user, which was a T-session component. Then you had the concept of a database and that database would point to a specific directory where your files were stored, or it would point to a particular Borland SQL Links driver, and it's through the database that transactions are supported. Next, you have the datasets, which gives the TDataSet interface its name, and that included queries, tables, and stored procedure components, and these could also be used to work with SQL views. Finally, each dataset, which consists of 0 or more rows, has individual T-field instances which represent the columns. And so whenever you hear me talk about the TDataSet interface, I'm talking about this kind of orientation. With FireDAC, the TDataSet interface is represented by a number of different components, and I'm going to focus on some of these as we go through this presentation today. First of all, you have the FireDAC Manager, which is a singleton component that represents the overall configuration for your application. Next, you have FD connections. FD connections represent the user and a connection to the database. Most applications are going to only have one FD connection, and that connection will connect your application to a particular database. If you have multiple databases that you need to support, you'll have more than one FD connection. And if you need multiple connections to the same database, such as in a multi-threaded application, you will also have multiple FD connections. Essentially, you'll have one FD connection for each thread. The datasets themselves are represented by the FD table, FD query, and FD stored proc components. And those are the components that you use in order to retrieve data. You can also use an FD command to execute SQL statements of any kind. You can also use an FD connection to execute SQL statements directly if you need to. And you'll notice that any one of these data sets, they point to a specific FD connection. And again, that FD connection represents the user. Now, there's other components that are actually, there's a whole lot of components in FireDAC, and I'm just going to focus on just a few of them. Some of these other components are the FD mem table, which is very similar to a client data set. There's an FD update SQL, which is a component that can generate a number of different parameterized SQL statements, such as insert into queries, delete queries. They can also be used to do update queries. There's transaction components that you can use, although you also can start a transaction with an FD connection. And this hierarchy is important for another reason, and that is it represents also the inheritance of application configuration, and that's a topic that I'm going to be talking about next. So let's pause for a minute and take a look at what FireDAC is. Well, first of all, it's a comprehensive data access framework and the most complete support for the TDataSet interface of any of the data access mechanisms available within RAD Studio. It provides a smooth migration path for legacy applications, and it has an unmatched collection of capabilities. FireDAC features include an incredible TDataSet compatibility. As I said, it's the most complete TDataSet interface implementation. It has cross-platform support for both the VCL and FireMonkey applications. It has exceptional support for databases. Specifically, it has native drivers for a very large number of the most popular databases. And then for those databases that it doesn't have native drivers, it has the bridging ODBC driver. So any database that supports an ODBC driver or has over an ODBC driver for it can be accessed with FireDAC. It is highly configurable with configuration inheritance, and I'll go into that in some detail. It has built-in dialog support, data type mapping. It has results set persistence so that you can save and retrieve your data using a binary format, a JSON format, and an XML format. It has transparent connection recovery, which is configurable. It has built-in support for concurrent queries, and it supports SQL scripts with logging and incremental stepping. It supports local filtering and dynamic index support, native support for both local and remote query monitoring. There's a powerful query preprocessor that I'll show you. It also supports aggregate fields and group state. It has a local SQL engine with support for querying TDatasets using SQLite syntax. It has support for cached updates, support for batch SQL processing in a feature called ArrayDML. It has support for nested transactions and those databases that support nested transactions, such as Interbase and Firebird. And it has support for selected database services, such as backup and restore. And importantly, it's written in Delphi, and that's why it is cross-platform, because it's purely Object Pascal. FireDAC and configuration. Connection configuration is performed through 4 connection properties. These are fetch options, format options, resource options, and update options. Connection configuration can be inherited. FD connections inherit from the FD manager, which, as I mentioned, is a singleton object. The FD mem tables inherit directly from FD manager, and other FD datasets inherit from their FD connection. Inherited configuration settings can be overridden, so you can customize individual FD datasets. Let's go take a look at that. Now I'm using Delphi here, so if you're using C++ Builder, obviously the language will be slightly different, but the components are the same and the properties are the same. So what I have here in this little project called config demo is I have placed an FD manager. Now I actually don't have to place an FD manager in order to configure FireDAC. If I don't place an FD manager within my application, one will be created for me, and there's a global variable called FD manager that we can use to access it programmatically. But if I want to configure the FD manager at design time, I just simply place one somewhere within my application. Typically, this would be placed on a data module. That's the logical place for an FD manager to appear. The FD manager has those options that I was talking about: fetch options, format options, resource options, and update options. The FD connection has that as well, and as I said, it will inherit the configuration of the FD manager. In fact, all FD connections will inherit directly from the FD manager. And then the FD query will inherit its settings from the FD connection that it is connected to. And let me show you how that works. I'm going to select the FD manager and go to Update Options, and I'm going to scroll down to the Update Mode. By default, the update mode is upware key only. Frankly, I don't like that setting as a default, because what it means is that if two users are editing the same record, the last one to post is going to win out, and their changes will override the anybody who posted before them. And I find that not a good setting, because the people whose data is being overwritten are never informed. They have no way of knowing that their data is lost because somebody posted after them. The setting I prefer is a setting called upware all, and in that case, if a person posts to a record and someone had previously made a change to that record since the first person actually read the record, then the update will fail. In other words, where all will include not only key fields, but all fields, all non-blob fields in the where clause of the update statement. And what it means is the second person to post actually will have their update fail. But they're informed about that. So what they can do is reread the record and then make another change on top of that, and that will post. So once I made that change, notice that on my FD mem table, in my the upware all has changed for that table. It's or for the mem table. It's also changed for the connection, and it's changed for the FD query. Now, if I come down to the FD connection and change this back, let's say we're upware changed. That actually allows two or more users to post data and have their data actually merge, as long as neither of them had changed the key fields or the same record. So one person could change address 1 and another person could change a phone number, and they both would be able to post to the record. Since the FD query is connected to that FD connection, you'll now see that the FD query is also using that particular value. You may ask, how can I override that? What if I want this particular query to use upware all? Well, when I set upware all, we'll see up here in the assigned values that there's a flag that got set. And basically that flag tells FireDAC that any changes to the component in which you're editing from will not be inherited. So it basically disconnects the inheritance feature of this value. And if we actually go back and remove that flag, what we'll see is it will now go back to inheriting from its connection or from the FD manager. So that's the inheritance capability of FireDAC, and it's really quite powerful. Again, I will stress that typically your FD manager and FD connection, those components would appear on a data module in most applications, since you typically only have one connection and you by definition only have one FD manager. Individual queries may or may not appear on a data module depending on whether they're being shared or not between multiple forms or frames or other data modules. Next, I want to talk about FireDAC indexes. An index is a client-side structure that contains an ordered set of pointers to records in your FireDAC dataset. Now, you may be familiar with indexes on your database, but they are entirely independent of the indexes in your FireDAC datasets. Specifically, you may have 5 indexes on a particular table in your database, and when you query that table into a FireDAC dataset, such as a FireDAC query, there will be no indexes on the FireDAC query, and that's what I mean by the indexes are completely independent. If you want indexes on your FireDAC query or any other FireDAC dataset, you actually have to define them. And you can define them at either design time or at runtime. If you define them at design time, those indexes will be created automatically by FireDAC once you select them. And you select them by setting the index name property. Now there's 2 kind of general types of indexes, and it's interesting with FireDAC, the concept of a temporary index doesn't really hold true for FireDAC datasets as much as it did for the client dataset. In the client dataset, we referred to indexes created using the index field names property as temporary indexes because they only existed as long as the index field names property was set. If you change the value of the index field names property, the existing index, if there was an existing index, would be destroyed and a new index would be built. It turns out that in FireDAC, it actually keeps around these temporary indexes. So they're technically not temporary in the same way that a client dataset index is. It's also more powerful than a client dataset index because you can create both ascending and descending indexes using the index field names property. If you want a descending index, you do just like I did here. You separate the name of the field on which you want to index with a semicolon and then a letter D. And that letter D denotes descending. By default, the indexes when you use index field names are ascending. So in this case, an index with this value assigned to the index field names property would sort in descending order by last name and ascending order by first name. And as you can see clearly here, if you want a multi-segment index, that is an index on multiple fields, you would separate those field names with a semicolon. Persistent indexes are ones that are defined with the FD index. It's actually the property is called indexes, and it can contain a collection of 0 or more FD index definitions. Now, this is where you have a lot of power in FireDAC. These index. By the way. All of the FireDAC index, that is, all of the FireDAC datasets have an indexes property, but the FireDAC mem table has a property called index defs, and that's for a API compatibility with the client dataset. But let me just say, do not use the index defs property. That's not how you work with a FireDAC mem table. You want to use the indexes property. And in fact, in the little example I have, the first thing I do when the application runs is I blow away any index defs that happen to be sitting around, because they can really mess up indexes in the FireDAC mem table. I will say at this point, though, that the need for a FireDAC mem table is much lower in a FireDAC application than you would have in a client dataset based application because all of the FireDAC datasets support these concepts of the temporary indexes and the persistent indexes. So After you execute a FireDAC query, you can use either temporary or persistent indexes, and this is the only data access mechanism in RAD Studio that I'm aware of where there is the general TDatasets support these kind of on-the-fly indexes. There are 4 categories of persistent indexes. There's field-based indexes, which just is, as it says, it's one or more fields produce a sort order of the data in the FireDAC dataset. There's expression-based indexes, which allow you to use a variety of different scalar functions as part of the index. You can also include constants or literals within an expression index. There's distinct indexes, which they're different than unique indexes. A distinct index will just filter out a data set to show only one combination of the index values, even if there's multiple. So imagine you have a table with addresses, and one of the fields is the state of the address. If you apply a distinct index to it, there's only going to be one state. If that's your expression is the state and it's a distinct index, even though there may be many thousands of records for each state, you'll only see one record for each state, and that is a actually pretty cool index. And then there's filter-based indexes, which provide a combination of the power of filters in FireDAC with the speed of an index. And a given index that you create may actually have multiple characteristics. If, for instance, it could be an expression-based index that's also distinct. And if you spend a little time thinking about what those might look like, you'll start to realize that there's a tremendous amount of power here. So let's go back over to Delphi and take a look at an example of this. Okay, there we go. So in this case, just for ease of use, I've used an FD-mem table, which I did that because it's I've got data loaded into it, which makes it, it's just easy for me to manage with this FD-mem table here. I would have liked to have used an FD query, and just be aware that everything I'm showing here can be done with an FD query as well. So my index field names, if I had this active, if this was an active data set, I could have just typed in field names here and it would create an index on the fly. But what I'm going to look at right now is in this indexes property, and you can see I have a number of indexes here. So let's take a look at this index. This is a field index that says that the index is consists of the first name field and then the last name field. I could have put a :D here to define that the GUID is descending, but instead I also have a descending fields property where I can put a list of the fields that I want to be sorted in descending order. And a very important part of this is that we have to give the index a name, and that becomes the name that we set in the index name property of the data set in order to select this index. And I've also enabled the active property, set that to true, and that tells us that this is an available index. If active is not true, you can't set to the index, set the data set to that index. Now here's another one. Here's one that's actually using an expression. And in this case, the expression is length of last name. And notice that I've given it a kind of descriptive name here. Here's a distinct index, and you'll notice that, I needed this set distinct to true, but city distinct is now a distinct index, and no matter how many times a given city name appears in this data set, we'll only see one. They're all there, they're still in memory, but they'll be distinct. And then here's another one. This is a filter index. The filter is first name equals K star, which is a partial index, but basically that star says any characters, any additional characters, and this will limit us to just first names that start with the letter K. I've set up a filter option that says that it is case insensitive and it is a partial index. And by the way, these, if I remember correctly, and of course I wrote about this in the book, but I'm not going to look it up right now, but all of these indexes are case insensitive. I don't think that there's a way to make them case sensitive, but I've set it as a partial index and on the first name field, and its first name starts with a K. Now, in this project, I've also set up a method that is called create runtime indexes, and this shows how those indexes could be created at runtime in code. So here is an index that, notice the fields here, I've got first name and then GUID by in descending order. Here's another one. This is making use of one of the SQL scalar functions in FireDAC, and it's the random function. So I'm creating an index based on a random number, which is kind of interesting. And here is a distinct city-state combination. It is a distinct index. And here's one where an index where the first name is Ruby. So this is actually created, if we look at the onCreate event handler of this form, you'll see that I'm clearing the index defs of the FD-mem table, and here I'm loading data. By the way, the example I have has a file in it called Big Mem Table, which has just about 25,000 records in it. So I wanted to, it does mean that the download is pretty big. It's over 4 megabytes when you download it, but I wanted to have a large data set for some of the examples in the Delphi in-depth FireDAC book, and that's what I've done here. So we create the runtime indexes, and then I have a little routine called list indexes, which iterates through the indexes property and will display the name of the index in a drop-down combo box. So let's go ahead and run this. And I'm not running the right one. I need to run this one. Okay, let's go ahead and run it. Okay, so let's go ahead and select an index. Here is by first name, and then by GUID in descending order. Here is last name begins with K, or I'm sorry, first name begins with K. And here's the Ruby index. And I put RT there to indicate that it's a runtime. Here's a distinct index. So if we went over and looked at city and state, there's only one combination of each city and state, even though there's, and notice here that there's only, now that we have filtered that, there's only about 15,000 records instead of 25,000. And I'm going to go back up here and go to the no index option. And you'll notice there it is, almost 25,000 records in that example. Much of the editing that you'll do will be based on a SQL select statement, and that will populate your FD query. Like I said, FD table is there for compatibility with the T table from the Borland database engine. Most developers are going to use the FD query simply because the SQL is a very expressive language, and it allows you to do so much so efficiently on the database server. While I'm on that topic, I should mention that if you're using the professional edition of RAD Studio, you are the license only allows you to work with local databases such as MS Access or Paradox through the ODBC drivers. You can also work with a local version of Interbase that does come with it. But if you want to be touching a SQL database like Oracle, Microsoft SQL Server, or Interbase, you're going to need at least the Enterprise Edition of RAD Studio. The FireDAC query can also make stored procedure calls, but there's a FD stored proc component that you can use, and the one advantage that it gives you is that once you point to the stored procedure, the params property of the FD stored proc component will show you the various parameters of that stored procedure. If you are already familiar with the stored procedure, you could just write an execute procedure statement or the equivalent of for whatever your database is in an FD query. And so it's really a kind of a generic component that that you would use in order to work with your data. Now, with the FD table and the FD query components, if they return an editable result set, and FireDAC will try to do that by default, in most cases, you can edit that data set directly, and when you post the data will be written back to the underlying database automatically. If you have a heterogeneous query where you're linking, you can actually go into the update options. The property is, I think it's auto update table, and specify which table you want to write the data back to. And that will allow you to write back automatically in many cases. Some queries, though, are too complicated and are really not editable. And in those cases, you will have to take one of the alternative actions in order to write the data back. You may capture the data, possibly using cached updates, and then either write an on-update record event handler for your FD dataset, or possibly use the FD update SQL component. You have a number of options for working with that. So again, talking about basic navigation and editing, when you open a data set, which you do by calling open or setting active to true, as long as it's not empty, the cursor will be on the first record of that data set. And in RAD Studio terminology, we refer to that as the current record. And you can change the current record using one of the dataset methods. And there's a whole lot of them. First takes you to the first record, last puts you on the last record in the result set. There are searching methods such as find key, find nearest. You can say move by to move by a relative, a number of records. Recno is, you can read to find out which record you're on. You can also set it. It's a writable property that when you set it, it actually moves to that record. So if you wanted to be on the fifth record of the result set, you could say recno equals 5. Find first, find next, and the other find methods are used in conjunction with a filter to navigate based on the filter. You have locates, you have locate X, filter, go to nearest, go to bookmark, insert record, append record, and set range. All of these can change the current record. And that's a pretty thorough list of the types of methods that you're going to use programmatically. Now, the other thing, too, is if you've got the FireDAC dataset wired up to a visual control, and that visual control allows for navigation. For instance, a DB grid, the user, if you've got the FireDAC dataset hooked up to a DB grid, the user can move around on that record and actually start editing a record directly if it's an editable record. And so you can have a lot of editing done without your code being involved at all. But of course, we do quite often need to programmatically edit data. In that case, you start the editing session on a given record by calling the edit method on the FireDAC dataset. It'll raise an exception if it's a not editable record. And after you're done editing, you can either move off the record programmatically by calling next or something like that, or you can call post. That record will be posted to the underlying database as so long as the any constraints on that database are not violated. So if you had a key violation, you would not be able to. You would actually have an exception raised by Delphi. Same thing would happen if you had the user just simply using the user interface to edit a record, and then they moved off it by posting, or if you had a DB Navigator or a similar control like that, where they clicked on the post button, it would raise an exception if it violated any constraints. And just, I've got a number of projects that demonstrate both navigation and filtering and searching. Those are all available in the code download that I'll show you the URL for at the end. But here's an example of a database that demonstrates the editing. Here we can, when we say next, we go to the next record. Here's actually the DB Navigator object. We have right now 15 records displayed. I'm using recno in order to show that record. I've also created a timer. I'm using actually a stopwatch to demonstrate how long a certain operation is taking for it. For example, scanning forward through the database, scanning backwards through the database. Notice it's taking about 102 milliseconds. You can disable controls so that you don't actually see the cursor moving, and those operations are much, much faster because RAD Studio is not having to repaint the screen every time. So take a look at this one. While I'm at it, let me just open up the File Explorer here and show you the amount of examples that are in the code download, just to kind of get you thinking about it. These examples demonstrate so many various features of FireDAC. So have fun with that, and if you need detailed information about it, you can either look up in the RAD Studio help, or you can pick up a copy of my book, because I explain every one of those projects in some detail. Okay, back to our slides. Okay, the SQL command preprocessor. I decided to include this one because it's really interesting that it gives you a great deal of power, and especially if you have to write an application that may need to work with more than one database. Say, for instance, that your company supports both Oracle and Microsoft SQL Server. As a SQL programmer, you're familiar with the fact that different database servers have different dialects. And the SQL command preprocessor lets you go a long ways to supporting both multiple databases without changing your code. In essence, FireDAC will detect, hey, I'm talking to Microsoft SQL Server, or I'm talking to Interbase, and it will adjust your SQL through the preprocessor. So there's a number of things that the preprocessor can do. One is it allows for macro substitution. Macro substitution is like placing a variable in your SQL statement. You do that by having a symbol, which is basically a word, and it's preceded by an ampersand. And each one of those is referred to as a macro, even though it's really a variable. And just as long as you assign a valid value to that macro prior to the execution, the preprocessor is going to substitute that value in at the time of the execution. Let me show you a kind of a nifty example of this. Actually, let me go back and close down this running project, and we'll go to, let's see, macro substitution. I believe this is the project. And this is actually the only FireMonkey example I have. And what I'm going to do is enumerate the tables in the underlying database. And when I select a table, it'll show me fields. Whoops, I didn't get the right one again. Okay, here we go. And Anytime I select a table, I go through and enumerate the fields, and that might be fun code for you to look at just by itself because it shows a lot about what the T fields are like and can do. And then I am able to select the fields I'd like, and I build a query on the fly using this technique. And when we go and look at the data, there's two macros in this statement. One is for a list of fields, and I build that list. There's a little function I wrote here called build list, and it goes through and creates a comma-separated list of the fields. Now, those fields better not have spaces in them, or this doesn't work. I could have accounted for that if I wanted to, but I didn't do that. Let's actually look at what the query on here looks like. So I'm going over to the data module. And here's my select query. I'm bringing up the FireDAC query editor, and it just says select ampersand field list from ampersand table name. And so all I have to do is assign the table name and the list of fields to these two macros before executing, and it will execute a statement that in this case is a valid SQL statement. So that's an example of the macro substitution. Now, the escape sequences are probably a little bit more exciting, and there's 4 types of escape sequences that are recognized by the command preprocessor. Constant substitution allows you to embed constants within your code, and the constant will be represented appropriately in the format that the currently connected database requires. So a date, if you have 2 different databases that represents dates slightly differently, you could specify a literal value in your query using constant substitution, and FireDAC will format it correctly. Identifier substitution allows you to specify field names, and those field names will be enclosed in the proper delimiters that particular database. A lot of databases use, let's say that your fields have spaces that in most database servers, you're going to enclose the field name in double quotes. When you do identifier substitution, FireDAC puts it in the appropriate delimiters to identify that literal value. Conditional substitution allows me to have essentially if then else, or if immediate ifs, or if this or that or another thing. And what that does is it basically allows you to say, here is a value, and I want to represent it this way for Interbase. I want to represent this one for if I'm attached to a Microsoft SQL server, so that you can, if you're trying to increase the performance of your query by using syntax that's appropriate for this server or that server, the conditional substitution basically allows you to do that, so that you say, this is how I want to format this statement when I'm talking to Interbase, but this is the way it should look when I'm talking to Microsoft SQL Server. And that's terribly, terribly valuable. And then finally, the FireDAC scalar functions there's a large collection. It must be 60 or so different functions that you can use, and FireDAC will drop in valid values. So you could do substrings, you could do various numerical functions and arithmetic functions. You can do date-time operations, and I strongly suggest looking at the FireDAC help for the SQL scalar functions. You'll find that there's a real wealth of stuff there. And again, what happens is the SQL command preprocessor will examine this query and then execute the function as part of it. Now, I'm going to show you a project that will allow you to play with this a little bit, and it's pretty cool because it'll show you the end result of the SQL command preprocessor. However, I'm going to warn you right in advance that when I run this, it's going to fail. and I want it to fail for a very specific reason, so I can point out something that I've noticed on some of my interbase installations. And by the way, all of these examples, almost all of them use interbase. They either use the interbase, one of the two interbase databases that ship with RAD Studio, or they use my big mem table that's like 25,000 records. This one definitely uses interbase. And let me show you here that what I do is after I'm done binding any macros, then I'm preparing the query. I'm preparing the query if there's macros there, and then I'm reading the query text, and that's the post-process text. Now, right, as I said, it's not going to work first off the bat, and I'm doing this for a very specific reason. So I say prepare, and it came back and it said unknown function unknown string length, or so there's a string length function. Now, if you see what I've done here, I have a query, and here's a function that's going to be replaced. So I'm saying I want to execute and get the length of first name. That'll be one of my fields, and then I want to get the last name. Now, what's going on here is this. There is a SQL file that needs to be executed by interbase. And in the appendix of my book, I talk about this file. In this case, it's called UDF, but in the case when I wrote about it in the book, it was called UDF_DB.SQL. And I happen to have that file open right here. And what it does is it creates a number of user-defined functions in interbase. Maybe one of these days, these user-defined functions will actually be built right into interbase, but you have to run this file. And if you run this example and it comes back and it says it doesn't understand what string length is, then you're going to have to go in and do what I'm doing right now, which is I've selected everything here and I'm copying it to my clipboard. And then I'm going to come over to the Data Explorer, and I'm going to open up interbase in the FireDAC tab of the Data Explorer. And it really doesn't matter which of these aliases I get to, because all I'm really trying to do is come out and go to the SQL script page of the FireDAC connection editor. And I'm going to paste that code in here, and then I'm going to run it. And here we go. And okay, I'm going to move along. So that was the SQL command preprocessors. Very, very cool, very powerful. The next thing I'm going to demonstrate is ArrayDML. This allows you to create batch commands that whenever you have a large number of parameterized queries to execute, so you have the same parameterized query, but you have many different parameters, this thing can increase performance dramatically. In the book, I write about a situation with one of the teams I was working on that one of the developers had to insert 18,000 records into a table, and I showed him this ArrayDML, and he went off and did it. He came back just with the biggest smile on his face. He said, "You know how long it took those 18,000 records to be inserted? It took about a second." And I was like, that's nice. And so basically what it does is it allows you to define a parameterized query and then build an array of all the parameter values and then pass both the parameterized query and that array of data to the database server in one operation. And then the database will perform all of the queries and do all the query binding too. So you don't have to have all this traffic across the network. These batch commands are natively supported by most of the servers that are supported by FireDAC. And for those servers that don't support it, it still works. It just, in the background, FireDAC is doing the old-fashioned way of binding parameters, executing one query, binding the next set of parameters, executing another query, and so forth. So it doesn't, in the case of emulation, it doesn't gain you any performance, but it does allow you to have one code base, and when you do have support by the database server, it's very, very fast. So let's go over and look at this particular example. So what I'm doing here in this example is I am creating a table in my interbase database. And so I'm going to, let's look at the old-fashioned way of doing this thing. I say populate table using queries. And what I'm going to do is I am working with about 3,500 records here. That's what I'm going to insert. And basically, I'm going to insert 10 years of dates, January 1st, January 2nd, and on for 10 years. And so what I'm doing here is I'm trying to do everything I can to get the performance out of here. I'm starting a transaction. I'm using a stopwatch to count how long it takes. And I am binding the parameters, and you see that here. And then I'm executing the query. And now that's how we typically would do a series of parameterized query executions. However, I also have a version that does it with ArrayDML. Now what I do with ArrayDML is I specify the array size, and then I just assign the arrays or the values to this multidimensional array, and then I pass the whole thing over to the database server in one step. Let's go ahead and run this and see the performance difference. And remember, what's happening, I'm inserting about, 3,600. I keep on doing this. I seem to really like my old projects. Okay, so here we go. ArrayDML. So I'm going to do this the old-fashioned way, and that took like 1.6 seconds. And you might say, well, that's pretty fast, but look what happens when we use ArrayDML. 228 milliseconds. That was more than 6 times faster. And notice I've got, there's a lot of data here. I inserted 10 years worth of data. So very, very nice feature. Next feature is cached updates. Now I could go on about cached updates for a long time, and I'm not going to. I just don't have time in this presentation to do that. But cached updates are an extremely powerful capability, and one that may very well be something that you want to use in your applications. There are certain areas of an application where I just really enjoy using cached updates. So if you're not using cached updates, what happens is that records are written to your underlying database one at a time. As you post individual changes, that data is immediately applied to the underlying database. So if you insert a record, after you leave that record or you call post, the record's inserted right then into the underlying database. When you turn cached updates on, you can edit one or more records and nothing goes down to the database. It's all in memory. It's kept in cache. And it's not written to the underlying database until you call apply updates. But before you call apply updates, you can do a number of things. For instance, you could examine what changes the user made to the data and confirm that they're valid changes. You could individually undo specific changes, or you can cancel all the changes altogether entirely. So it's an extremely powerful tool for examining data programmatically, and also you could even let a user review. For instance, I could show a user, you deleted these records during this session. Do you want to keep these deletions? Do you want to undo some of them, or do you want to just undo all of them? And cached updates gives me that capability. So the advantages of cached updates are that you can reduce network traffic, because if you go ahead and cancel all the changes without writing them down, there's all that network traffic where you haven't had to apply the individual updates. As I said, the changes can be previewed and edited either programmatically, or you could let the user see what they did. And really, it's true. You can show the user their deleted records. Individual changes can be discarded, and all of the changes can be applied in a transaction, as I mentioned. So you can have an all or none approach. FireDAC supports two models of cached updates. There's the centralized and the decentralized cached updates. Decentralized is kind of traditional, the way we would think of cached updates with a client data set. You have one data set and you put it into cached updates, and when you're done, you use that data set to apply updates and apply the changes, and then handle any errors that might be that might rise out of a failure. In the centralized model, you can have one or more FireDAC data sets, and then apply them all in one transaction. And the interesting thing about the centralized is FireDAC is very explicit. It keeps track of the order in which your records were posted into cache, and it will preserve and represent that order when it's applying the updates. Now, this requires a FD schema adapter to work with, and this is such a powerful capability in FireDAC. It's one reason why I would move from some other data access mechanism to FireDAC. And importantly, unlike with before FireDAC was added to RAD Studio, the only option you had for cached updates was to use a client data set. But all of the FireDAC data sets support cached updates. So you can use an FD query and place it in the cached updates mode and then apply the updates on that or that FD query, or you could cancel individual records and revert individual records, or you could examine the changes. You could say, show me all the inserts, show me all the deletions, show me all the modifications. And I'll tell you, one application that I worked with, one of the companies I consulted for, we had a form that had more than 30 data sets on it, and we placed that entire collection of data sets into cached updates mode, and it worked. It was really spectacular. So let's, I don't want to get into this too much. I do have an example. I've got several examples for cached updates. I have an example of cached updates that uses the decentralized model, and I've also got one that shows the centralized model. And I really have to say, if you want to really get into this, take a look at the RAD Studio help. There's quite a bit of information about the process of caching updates. Applying updates also, you can actually get programmatically involved. That's another really important aspect of cached updates. Or if you get my book, the chapter on cached updates is very detailed and has both these examples of the centralized and the decentralized model. Just if you want to take a quick look at this form, you'll see that I have, well, let's just run it a little bit. You'll see a number of interesting things. Oh, God, there I go again. Okay, basic cached updates, and let's run that one. In this case, I'm going to open the query, and I'm going to enable cached updates. And now if I make a change, you'll notice that actually I've got a field here that shows the status. So I can actually read the status of individual current records to, and in this case, I'm using calculated fields. And so I just posted a change to that. But now what I'm going to do is cancel updates, and it went back to the original value. I could have deleted 5 or 6 records and then canceled, and the deleted records come back. This example doesn't show how to display deleted records, but I talk about it in the book. Okay, the last topic that I want to talk about is really another really cool feature of FireDAC, which it allows you to execute a SQL in memory against any data set. And it doesn't, and I'm not just saying any FireDAC data set, but any data set, a T table, a T client data set, an ADO data set, or of course FireDAC data sets. And what it does is it uses the syntax of SQLite, and it supports nearly the full breadth of the SQLite syntax, and allows you to do what-if queries against your individual data sets. Back when I first started writing about client data set, a lot of people asked, hey, doesn't the client data set allow you to execute SQL statements? And the answer was no. Yes, it had a command text property, but it was passed through SQL. That client data set passed that SQL through to a data set provider, which in turn executed a query against the database server. So the client data set didn't have a SQL engine. Well, FireDAC does. And it allows you to have complex queries. I can join multiple tables together. I can have subqueries. I can use the macros in the SQL preprocessor, and that's really nice. I have one note though, and I say here it can be a bit touchy. Specifically, I've had situations where I've set up local SQL and it's working fine, and then I go in and tweak it a little bit, and then the whole thing falls apart. And I don't know if it still does that, but my experience over a number of releases of RAD Studio was once it fell apart, you just had to basically strip everything out and put it back in again and start kind of over, because somehow it got into a weird mode. But let me just show you a simple example of this. So we're going to SQL, and this time I'm actually going to make the project the active project first. So what I have on here is I've got a query against the sales table. I've got a query against the customer table. And I'm loading a client data set. Well, that didn't show. I can show the client data set. But then I've got this query against all three of those. Let's see, where do I do this? FD local SQL, the local query. I must be executing, defining the query in here. So I am constructing the query, and here it is right here. Select from these various tables, and then I actually have a macro in there, and it is so cool. I'm able to execute a query against multiple data sets in memory. And that's nice. So the chapter on local SQL goes into some of the nuance of things that it can do. There's a number of ways of identifying the data sets that you're going to query, and I support both of those in this particular application. Okay, well that brings us to the end of this presentation. In summary, FireDAC is the most complete implementation of the TDataSet interface available in RAD Studio. It's the data access mechanism of choice in RAD Studio. If you're going to access data and you're going to use one of the RAD Studio provided data access mechanisms, this is it. It has so much power, so much capability, and we've only touched on some of them. My book is over 500 pages long, and it has 17 chapters. I mean, so there's much more that I cover in that book. And FireDAC supports a very wide range of databases, including MongoDB, a NoSQL database. And then the other thing is that for most legacy applications, if you have old RAD Studio applications, they're typically, because FireDAC supports the TDataSet interface, it's very easy to migrate forward your legacy applications to FireDAC. Well, thank you for joining me in this session. We're now going to have a question and answer session. If you're looking for the code and the slides from this presentation, you will find that at www.jensendatasystems.com/FireDACbook/FireDACbookcode.zip. And once again, here's the URL for the FireDAC book. If you're interested in that, you can get this website here down at the bottom has links for multiple countries where you can purchase that book from Amazon. Or there's also a PDF version that's available from FastSpring. So I look forward to your questions. Thank you again for joining me.
Great. Thank you, Cary, for that fantastic webinar and of course, your book and number of other papers and such you've written over the years as well. Let's see. Is FD Manager required, or can you just start with an FD connection? And Cary says, if you do not place the FD Manager, one will be created for you. So it's created behind the scenes, and you can refer to it in code using the FD Manager global variable. Yes, usually I've never used an FD Manager, or most of the things I've done.
Jim, can you hear me now?
I can hear you now. Okay, great.
Oh, wonderful, wonderful. I've been talking for a couple minutes. I haven't heard you, but what I'm going to do is, what I was saying was that there were quite a few questions, and I'm going to go through and actually address them all. I've answered almost all of them online as the presentation has gone on, and this Q&A session is also going to be covered in the replay. It is going to be lengthy. I'm willing to sit here and answer questions until there are no more questions or I fall over from exhaustion. So let's start off. How's that sound, Jim? Are you good with that?
I am good with that. Absolutely.
Okay, so I'm going to go past all the questions about not hearing the presentation. For those of you who had difficulty with either the audio or the video, we apologize. That is not something that we can control. Hopefully, but we will have all of this available from the replay, and everyone who signed up for this presentation is going to be given a link to the replay so you can look at it again later. If you have to miss this part because you've got to get back to work or to other obligations, you'll be able to scroll forward to the end of the presentation and hear this segment. So let me see here. An early question was about the batch move FD batch move component, and I apologize, this is not a component that I worked with. There were several pretty interesting components that I wanted to cover in my book, but the book started getting long. FD batch move was one of them. The other one was the T script, and if and when I release a second revised edition of the book, I'm going to be adding chapters on that. Okay, and someone asked a question that I actually answered during the presentation, which is it necessary to place an FD Manager component into your application? The answer is no. One's created for you if you don't have one. You only place one at design time if you want to configure the FD Manager, which again is those settings are inherited by the FD connections and then therefore by the FD datasets. So if you want to do configuration over the entire application at design time, go ahead and place an FD Manager. It's not necessary. You can actually touch, using the global variable FD Manager, you can touch the auto created one at design time. Let's see here. I'm going to skip the question about sleep mode in a MacBook Pro. That's a hardware question. I'm a software guy. Okay, in a multi-threaded application, the attendee asked, I've put a connection and the data set on each thread. Is this correct? Absolutely, that's the way to do it. If you reuse a connection for your various threads, you're going to have to synchronize them, and then you lose concurrency. A question about configuration, asking if I will be covering specific configuration, and really the answer there is so much. There are so many options to configure FireDAC that it is just not possible to talk about every configuration option and how it interacts with other configuration options. I mean, such a book would be thousands and thousands of pages long and would probably change incrementally over time as FireDAC gets improved. It's a matter of making yourself familiar with the options that are provided, which are there are just numerous options that you have, and trying to understand your database, and then trying various things. If you have performance issues, test. Someone asked what functions can be used in an index. RAD Studio has a collection of about, I'm going to guess, it's about 10 or so functions that are built in, things like length and substring. But you can use any of those, and you can use that with any data access mechanism in your expression indexes, regardless of the data access mechanism. And however, FireDAC has a large number, and I threw out the number 50. I never counted. It could be 70. It could be 90. There's a lot of functions. My book lists the functions and gives a brief introduction to each. You can also find those in the RAD Studio help. Let's see here. If you go to the chat, I'm gonna do something in the chat line for everyone. Someone asked about the location for the source code. What this is actually the download location for the source code from FireDAC in depth, and I am making all that source code, including this slideshow, available to all attendees. And in the chat area, I have just posted to the entire audience where that source code is available now. The URL for the code was on that final screen, so I've just placed it into the chat window. And will you implement this example with Noble Apps? No, I will not. Where do you find a client setup guide for FireDAC? Client setup is discussed actually in the FireDAC documentation. They talk about how to connect to each of the various databases, just give a kind of a high level overview, but and they don't specifically talk about the client, because client configuration is the same as it would be in any other situation. First of all, you have to have the client API installed on the client. This is why a lot of the databases in FireDAC are not accessible directly from mobile applications, because most database providers do not provide a client API for either iOS or Android. You have to instead use something like DataSnap or RAD Studio to talk to a middle tier, and that middle tier will probably be on a Windows server or Linux server, and the API for your database will be provided for by the database provider.
I can comment on the mobile client. I've used FireDAC on desktop and mobile quite a bit, and it all works on the mobile as well. The difference is, as Cary just said, that you have to work with databases that are supported on mobile, so that is limited to SQLite and Interbase.
Right.
Interbase is a bit more robust, whereas SQLite has because SQLite's built into the OS already, the mobile OS already, it's a little easier to deploy because you don't have to deploy the SQLite embedded database. But once you're set up and connected to one of those two databases, all the stuff, I haven't tested everything, but pretty much all the stuff Cary showed should work just like the same on your mobile app.
Yeah, for any database for which there is an API, and so that's what Jim's saying. Someone asked, can FireDAC be used in parallel programming using T-Task? And in order to answer that, I was opening up some papers that I wrote for Delphi Developer Days on parallel programming, and I was looking up the parallel library and never got to that. I don't have an answer for that right now. I haven't tried using T-Task with a connection. There's issues here. If you're using a thread, if you're instantiating a thread, on the construction of that thread, you're typically creating a connection and configuring it with information provided globally by the application, and then you are instantiating your FD queries to connect to that particular connection within the thread. So there's a life cycle of the thread, and that simplifies life. TTask, if I remember off the top of my head, is a very transient kind of thread, and it would be actually a lot of work, I think, a lot more work to use a TTask rather than instantiating a thread that has some, as I said, a life cycle that's more lengthy and would justify the creation of a connection. Now, adding to that, I would say you want to configure your FireDAC driver to use thread pooling when you're doing this, because the connection itself is an expensive process relatively, and if you're using thread pool, then the actual each time you're instantiating a new thread and creating a new connection, you're probably using a connection from the thread pool and not actually making a new connection to your database. Okay, next question. Is RecNo 0 or 1 based? It's 1 based. So setting RecNo to 1 takes you to the first record in your database. Someone asked, is there a discount for the book for listeners? I am sorry. I wish there's no way that can be done. And I tell you what, working with Amazon and FastSpring, we have to play by their rules. And I don't want to complain, but their rules can get kind of difficult sometimes, and so I don't want to mess with that.
I can comment on that as well, and I found all of Cary's content to be just incredibly valuable, and a number of people in the comments have commented that they have your book and love it. So pretty much whatever price Cary charges for it, it's already discounted. So,
well, I appreciate that. When I undertook that book, I had a lot of material already for FireDAC, and I thought I'll be able to pound this out in a month, and no. I got into it. I said, this really is, I need to do this. I need to do this right. So I've spent a lot of time. And so thank you very much for that comment, Jim. Someone was asking about ArrayDML and the size of the batches. Actually, there were several questions. So I'll answer those questions about the number of records you can apply in a single call to execute. Internally, FireDAC is going to try to determine the proper batch size. So I'm doing this off the top of my head, and I'm pretty darn sure that you could put 1 million records into the params array, but then FireDAC's not going to try to send all 1 million records, because many of the database servers have a limit as to what they can do for these batch commands. And therefore, FireDAC will try to determine the correct batch size, 10,000 records or 20,000 records or whatever. And if it if it fails, you can actually control that through the resource options.array.dml size property. So that's how you address that. And so it's basically on an application by application basis. If you run into problems, take a look at the various options that FireDAC gives. In so many cases, FireDAC gives you the capability of controlling what's going on through those resource options and the format options and the fetch options and the update options. And that's why it's so important to familiarize yourself with what's out there. And then when you run into a difficulty, go and take a look and see if there's something that will let you configure it. Someone asked, are macros not a problem for SQL infiltration? And I'm assuming that questioner was asking about SQL injection. Bottom line, if you create a where clause and one or more of your predicates are created by concatenating in something that a user enters in manually, you're in trouble. You're exposed to something called SQL injection. Somebody who knows what they're doing could terminate your statement as part of a SQL batch and then put in something very destructive or something that exposes your data, like drop table customers or somehow select data and actually display it through your interface. Macros are concatenation. Okay, so you must be aware of that. If you're using macros simply for the values of the where clause elements, so for instance, I say where customer ID equals, and then you have a macro, you don't need to do that. You should use a parameter, because parameters are immune to SQL injection. The important thing about macros is you can use them in places where it is not possible to use a parameter, for instance, in the table name or in the select clause to refer to specific fields. However, be careful. Don't just get the value of the macro from the user and then place it in there. I would use it as for the table name only if the selection was necessarily limited to actual table names, or if you are really, if you're really careful about it and you examine what value you're going to assign to the macro and make sure it doesn't have any semicolons in it, or it doesn't have any other or comment lines, anything that would then short circuit the query, then you're okay. Someone asked, what is the better FireDAC approach that you guys point to using to do complex CRUD operations in master detail and tier applications? Oh, I missed the N-tier application part of that. Well, centralized cached updates allow you to have complex create, read, update, and delete, create, insert, create, read, update, and delete operations, CRUD operations in master detail examples, including very complex examples. And in terms of N-tier, I certainly believe you can do that N-tier. You're going to be working a lot with complex cache update definitions on the client and sending it to the server. I don't see why it wouldn't work, and I've done it in situations, but it is complex, and so you're going to have to really understand cached updates. You're going to really have to understand the N-tier environment, but FireDAC and RAD Studio combined give you access to all that data that you need. You're just gonna, it's not a trivial thing. It is something that is really a much more advanced operation, or I should say requires a fair amount of sophistication in terms of your experience with RAD Studio. So, okay, someone was asking about migration from the BDE, and there is I would call it a utility or an app that ships with RAD Studio that will examine your BDE application and convert it over to FireDAC. My experience with things like this is that they're never 100%, but they will save you a tremendous amount of time. I think it's called Refind. There is a very nice video on YouTube that David I did that talks about the conversion, and many other people have also posted some examples, or there are some other examples on YouTube that have been presented over the years for Embarcadero that talk about Refind and go through the process. So that's what you look for.
Yeah, it's called Refind. It's covered in DocWiki, and I've not personally used it to migrate any production systems, but I have had a lot of people come back and say, if you're migrating from a BDE or any TDataSet based framework to FireDAC with Refind, it works. It gets you about 90% of the way there. The first 80%, right? And you have to do the second 80% still, but it does a lot of the heavy lifting, a lot of the tedious stuff for you. Right.
Yeah, that's a big time saver. And the beautiful thing is, if you are using the BDE, it is the simplest path of migration to go to FireDAC, because there's almost a one-to-one correspondence between the components. I will say this: if you've been using T-tables and you end up, after running Refind, it generates TFD tables. Personally, I would then go through and change all the TFD tables to FD queries, and if necessary, if the only thing you do is switch over to a select all from statement from the select all from whatever table you were pointing to, that's okay. But the FD query is the data set of choice in FireDAC, and I would use that if you especially have something like TFD tables that then you apply a range to. Why not just use a TFD query where your range is defined in a where clause? It's so much more performant, because if you take an FD query, do a select all, and then apply a range to it, FireDAC is just going to turn around and do the select where and then put the range in there. So at least that's how I believe it works.
I'll add on to that. I was using the TFD table when I first started out, and I talked to Dimitri, our architect behind it, and he said, use FD query whenever you can. It's really the recommended way to go. And I believe you can modify Refind to have it replace your T tables with TFD queries.
Oh, that's good to know. I have not used Refind personally, so that's good information. I hope so.
Yeah.
There was one question that got really, really complicated about the schema adapter and the TFD JSON data sets, and I believe this is a data snap. Yeah, it is a data set thing. As a very, very complicated question, and I know that I have, when I've worked with data snap, I have recognized that I have access to all the information I need to do some very complicated operations on the client, send what's necessary to the server and apply it on the server. But that is, again, a very advanced thing. It is, I believe it possible, completely based on what I've seen. I know that there's all the information there. I just haven't done it, and that is something that you're not going to just implement in an afternoon. Okay, let me see. I've already addressed the issues about RADML and the number of records. Someone asked if you can use a RADML to insert records into an FDMEM table. The answer is no. The RADML is actually using operations on the database server, and there's other ways to insert a large number of records into an FDMEM table. Basically, you can either use a command and an FDMEM table and a table adapter to move data from a query into an FDMEM table. If you already have the data in an FD dataset, you use copy dataset, or even if there are all your data sets you're getting this data from are FireDAC data sets, you can use the data property. I have an entire chapter, a chapter on client data, FDMEM table that talks about copying data into FDMEM tables, and I've got a number of examples in the code download that show the performance differences between copy dataset and copy and using the data property to move data from one data set to another, and performance issues, and you can play with that and learn a lot about that. Okay. There was a question about FDMEM table and undo and redo, and you can do undo functionality complete within data sets. I responded that yes, undo redo is capable. Redo is not. Redo is not supported directly in the cached updates. You've got undo. You do not have redo unless you build it your own on your own, and that would be a rather significant challenge. Okay, and there was a question about. Oh, and I really need to stress this, all of this editing in cached updates is not just a FireDAC mem table issue at all. It is a FireDAC dataset issue. You've got undo in and revert record and cancel. You have, and then to apply updates, you have that in FD table. Although FD table, you have to turn on cached updates before you actually activate the FD table, because it's incompatible with the LDW, the live data window that is supported by FD table, but not supported by the other FireDAC data sets. But with FD query, you've got cached updates and all of those operations. And someone asked about keeping, track of the transactions, so you can include an undo function in your program all the way back to your first change. Well, you don't have nested transactions in cached updates, but what you do have is save points. And so let's say that you have 50 changes to make, and every 10 you read a save point. And a save point is simply an integer. If you set the save point property of an FD dataset to that integer, it's actually going to revert cache back to the state it was in when you read that save point. So you could set multiple save points, and as long as your cache log is intact from the save point you want to set to all the way back to the beginning of your session, you can incrementally go back save point by save point. And that's something to take a look at. Someone asked, how would you use cached updates in an accounting system where there are multiple users accessing the data? You know, the data is not live in cached updates. Necessarily, when you're in a cached update mode, you're looking at stale data. So if you had a highly complex real-time system, you are going to have to build in your own monitoring framework on top of cached updates so that nobody can read records that are in memory with someone else, and that you somehow, now in terms of applying the changes, no problem. You, as long as you have upware all as the update mode in the update options of your data set, a second user who tries to override or overwrite data that a previous user has posted will fail, and fail with an exception, so they get warned. Your data has not been posted. Someone else has already posted data to that record or those records underneath you. You should also keep in mind, just in an application, if the user reads data and then they post one record, even if they're not in cached updates, the data that the user is looking at is stale. If you need a real runtime system, live data where multiple users or even multiple threads are posting data to common records, you're going to have to build in a system of synchronization so that you don't override data or you successfully post. So it's a very complex thing. So that's where I'll leave that. Okay. Is it possible to use FireDAC to connect an MSSQL database from an Android? And we've actually addressed that in the earlier question about support, direct access support from within. And so the answer to that is no. Someone asked about using a multi-detailed table update strategy where you have a master table and maybe multiple first-level details and then maybe some secondary detail levels. This is all the centralized model of cached updates. And I will say that with one team I worked with, we had an extremely complex form that had no less than 30 tables on it, and almost all of them were related in some way. We had one-to-ones and one-to-manys with sub-manys and sub-manys and so forth. And this is actually an answer that really deserves a more detailed answer. We implemented centralized cached updates, and it worked. Now let me describe to you why we did centralized updates. Prior to using cached updates, the user was given the opportunity to go across multiple tabs of this one form, and as they switched from tab to tab, the application saved the data. Well, actually, record by record, the application saved the data, and when they clicked on another tab, it necessarily posted the records that were on the tab you were leaving and going over to the new tab. The problem was there was a cancel button on this whole form. And the user could hit the cancel button and it would say, are you sure you want to cancel? And if you said yes, the form closed. What it gave the impression to the user was that they were canceling everything they did on that form, which was the furthest thing from the truth. They were only canceling what they had just typed and had not left that current record or had not left the tab. And so when I took a look at that, I said, if you want to have that capability, you're going to have to implement cached updates across the entire form. And if the user hits cancel, they can literally cancel everything they've done. Any of the posts that were occurring as they move from record to record or from tab to tab was all going into cache. We also got even more complicated than that. They could hit a save button to say, let me save what I have so far. And we kept track of that. So if they hit cancel, we tell them, you are canceling all the changes up to your last save. If they hadn't saved anything, then we didn't have to do anything. We just said, we are going to cancel all your changes. Without centralized cached updates, that would have been virtually impossible. With centralized cached updates and over 30 tables, we accomplished our goal. Now, having said that, there is a very interesting thing that happens when you have key master field, key detailed foreign keys, and these master detail relationships. And I talk about this I go into some very significant detail, and the book has an example that shows this, although it's working with interbase tables that have a lot of constraints, so it's kind of hard to demonstrate it. But when you insert a detail table into a master detail relationship with centralized cached updates, even though your master table you may have just entered a new record into the master table, and now you're entering detail tables, how does it create that link? Well, what it does is it generates surrogate keys that are just temporary. When you finally call apply update, centralized cached model will apply the records in order. And since you must insert a master record before you can insert a detail record, what it does is it inserts the master record and then uses the appropriate key that was generated at the time, if it's auto ink or if it makes use of a generator like interbase, and then it cascades that link down through the detail tables, substituting the temporary keys with the actual key. It's really brilliant. So sorry for spending so much time on that one, but it's a big one. A question is about dataset. TDataSet depends on SQLite for the moment. It's actually the FireDAC datasets in local SQL depend on the SQLite syntax, but according to the documentation, it's actually translated into TDataSet operations such as insert record, delete, and so forth, instead of actual SQLite operations. It's just the SQLite syntax is what is supported. Are there plans to replace SQLite? No, I don't know anything about that, but I would imagine the answer to that is no. This may be a different type of question, though, if this is a question about mobile, because mobile applications do support SQLite on the mobile device. RAD Studio does support interbase to go on the mobile platforms. So maybe I answered the wrong question there. It says, is one method more efficient than copy dataset to move a bulk of data from one dataset to another? Oh, I didn't answer that, but there is an answer. If all datasets are TFD datasets, copy using the data property. Now you have more control with copy datasets, but the data property is extraordinarily fast because it's just taking basically one memory structure and moving it from one T dataset to another T dataset or FD dataset. Let's see. Do you have plans to implement? Do I have a plan to give a RAD server session? No, not at this time. I wrote a RAD, well, for the EMS server, which is very, very similar to RAD server, I wrote a white paper, and that's available through the Embarcadero white papers download site.
We just had a RAD server webinar last week with David I, and there's a series of blog posts that are going up, and David I wrote a RAD server definitive ebook, and that's quite large. That's available as a free download if you're on Enterprise or Architect. So
fantastic.
Yeah, go out and find that. Good stuff.
Can you perform local queries, the local SQL against non-FireDAC datasets, for example, client dataset? Yes. In fact, that example that I showed you did exactly that.
And I want to comment on this. The local SQL is such an incredibly powerful function. And I did a skill print on this a few years back, and I was like, what's the most outrageous thing I could do? And I got like 6 different data sets, all different types of data sets from 6 different data sources. And I did a local SQL join across all 6 of them. And it worked brilliantly. And I'm like, it blew my mind. I cannot tell you about that enough. That is just so cool.
Since it said that the SQLite syntax, for the most part, there was only a couple things like, give me a second. alter statements, for instance, which doesn't make a whole lot of sense. But alter statements don't work, but inserts and updates do. I mean, I haven't played with that a lot, but I got real curious one day and say, for the most part, you're doing selects. I mean, that's the probably 99% of those local SQL queries. But I did an insert and the darn thing worked, and I was like, wow, that's pretty cool. It says, can you purchase FireDAC for use with C++ Builder? This is true both about Delphi and C++ Builder. The professional license permits you, it comes with FireDAC, but it's only for use in local databases. You can't, or local versions of the databases, you can't use it for client server applications. That's in the end user license agreement. So if you have questions about that, in the past, you used to be able to buy the client server add-on. I wish that was available for all SKUs. Apparently, if you have maintenance on an older version where you did have professional and buy, and correct me, Jim, but if I'm wrong, but if you have an older SKU where you did buy maintenance and you had professional and were getting the update pack, that you can still continue to do so.
Yeah, I don't know. You'd need to talk to sales. I don't understand all the different licensing possibilities, but
okay.
I know that it's not available now, but if you talk to sales, they can help you figure that out.
Okay, does FireDAC have a generic way to react to database server notifications? So yes and I don't know. The bottom line is with FireDAC, you can have notifications where the database server that you're talking to has an exposed mechanism for that. In some cases, FireDAC actually has a component for some particular database servers. I believe it has a component for interbase events. In other database servers I worked with, it's just responding to notifications is done through a call to a stored procedure within, and you do that within a thread that waits on the return of the stored procedure, and the stored procedure becomes returns in response to either an event trigger, something that is executed from within a trigger on that database server, or another type of notification from the database server that also that you're also waiting on. So if I needed to know when a table was updated, I might have a thread that's waiting on two events. One is the return of a stored procedure, and another is a return on another stored procedure that the server that actually, well, a return on another event that's triggered by the application itself when it says, we're not going to listen for that notification anymore. We are going to actually terminate the thread now, and that's done during shutdown. So I've done this with some database servers, and it's going to depend on your database server and what features it supports. Let's see, what is the best way to start if I've got an existing SQLite database that I want to connect to? Well, use the SQLite driver in FireDAC. Okay, let me see. People asking about buying the book. What is the roadmap for FireDAC in 10.3? Whoops, yikes, I've lost my place here. I can't talk about the, I don't work for Embarcadero, and Embarcadero has regular sessions that are open for the public where they do talk about the roadmap, and so just keep an eye out for that.
Yeah, I put a link in for the August roadmap, which has a few things in there. Also further down, I put some links to what's new in 10.3. But if you look at the roadmap, you can see what's coming in 10.4, and I believe there is a roadmap update coming in the very near future. So stay tuned for that as well.
Someone asked, what would be a good transition from Advantage Database Server? And they're asking me this because I've written 3 books on Advantage Database Server, and I think it's an absolute tragedy that SAP refused to sell Advantage Database Server to a third party. The database server, Advantage Database Server, still works. My clients who use Advantage Database Server, we're moving off it. I'm not really in the specific instances I'm aware of, my clients have chosen PostgreSQL, but I'm not going to. I don't have a suggestion that I can make there. Another question was, can you recommend a good source to find using FireDAC with XML databases? I don't know what an XML database is, other than just XML files. And while RAD Studio is very good with working with XML files, I don't have an answer to that one. Let's see. Why are we getting FD string to FD wide string issues while migrating from DB Express to FireDAC? I don't know the answer to that. I'm gonna have to come back and answer that. I don't know, but the issue might be, are you migrating from pre 2009, which is Unicode? So that could be the reason. Also, look at data type mapping in FireDAC. That may be the source, may provide a solution. Okay, so here's the question. So essentially, I no longer do use client datasets and providers from my old legacy applications. Yeah, for the most part, that's true. I will say there's one thing that client dataset can do, and it does it very, very well, and FireDAC memtables or FireDAC datasets in general don't do it yet. Now, that doesn't imply that it's ever going to happen, but probably number one on my wish list for FireDAC is to provide the same functionality for FireDAC memtable as the client dataset has when the client dataset loads through a dataset provider from the master table of a master detail relationship. And that master detail relationship could be one master table with 3 details and numerous third level details and fourth level details and so forth. What client dataset does is it sucks all that data into the client dataset and creates nested datasets for the detail tables. And that is just the coolest thing in the world. It allows me in one complex, dynamically created query to populate all the nested data sets in a client data set, and then I can take that client data set and persist it. I could write it to a stream and fire it off across the internet, and I have just passed a massively complex data structure from one application to another location. It's a great feature, and there's just nothing else like it. Otherwise, just about everything else you can do with FireDAC memtables, you can do with FireDAC memtables that you did with client dataset, and in many cases, with much more stability. When a client dataset situation gets really complex, or you get a lot of data, it kind of falls apart. Let's see. Someone says, "Can you tell something about refresh database after update in multi-user application?" Well, you're refreshing your query, you should be should be giving you the latest view. Other than that, I have nothing more to add than the obvious. So I don't have any. There's nothing good or bad to say about it. Let's see. I tried mapping rules at the FD connection level, but for some tables it is not working. Well, things get complex, and when they get complex, I've had, let me just share something. One thing I've learned over time is that if you keep after the problem and try various solutions, you most always eventually come up with a solution. I've worked with teams where very bright developers will try 2 or things. They'll come to me and ask, "Hey, how do I do this?" And I say, "Well, try this," and then they'll come back, "That doesn't work." Okay, well, it's like, try this, and they come back, "That doesn't work. I'm going to quit. This isn't going to work. I'm going to go this other way." You say, "Wait, don't just quit just yet, because it's there. Let's try some more things." And it may take a day or two, but in almost every situation that I can think of, we found a solution. It's just you got to get creative sometimes. You of course use your resources like Google, and use Stack Overflow. And of course, if you use Stack Overflow and you post a question, do your homework first and make sure that you tell in your question what you've tried, what it's failed, and what's it look like, so that someone can help you the best. But I've found in almost every situation, if you keep at it, but get creative. If something doesn't work, don't just try that same thing over again. Try some variations, but then try to think about alternatives that might do this. So let's see here. Using FireDAC Connecting Advantage, what would FireDAC do for me that's not available in the ADST dataset? I could talk about that for a long time, but everything. They don't have Advantage database or Delphi connectors anymore for the latest version of Advantage. You can fuss with the source code and get it to work, but use a FireDAC. I have converted all my Advantage database applications using FireDAC, because in that case you get a Radial, which actually it's emulated with Advantage Database Server, but you get local SQL, you get these really sophisticated indexes, you get the cached updates, you just get a wealth of things that FireDAC provides that you don't get from ADS. Let's see, is it now practical to load a large table and run a like query on it? Searching for a pattern in a field. I'm not sure if that's a question about local SQL or not, because certainly if it's to load a large table and then run a like query on it, I'm unclear if that's using local SQL, then maybe not. One thing I would consider doing, and going back to the indexes, a filter query is a really powerful tool. It gives you the speed of an index and the flexibility of a filter. It's really great. So I'd look at that.
I'm going to put a link here in the comment section, or in the chat window, to a blog post I did a while back on how to get answers to your questions. And I combined a number of things I've used over the years and different resources I've found. And it's like a bunch of steps that you can go through that when you're posting, like on Stack Overflow, how you can enable the person that's going to be answering it to get the answer you need. But I found from my personal experience that frequently when I go through these steps, I will find the answer on my own. When I am preparing to properly ask a question, usually I realize that I have not done something, because like Cary was saying, there's usually, if you stick it enough, you can find the solution, especially with Delphi and FireDAC, where you have the source code there. And if you go into the source code, you can sometimes see maybe there's something wrong. Maybe you made an assumption about how things are going to work, or maybe there's something you could change that could possibly be a workaround for you. So,
okay. Someone says, I don't program in Delphi, but in C++ or will C++ Builder, will the book be usable for me? Well, yeah. Delphi code is not that complicated to read at all. And I talk about properties and methods, and that's the bulk of what you're going to get from. No, you won't have the examples at your fingertips. You won't be able to just cut and paste, but you could read between the lines. I think the book would be very useful. There's a lot of code examples, but I am mostly what I'm really talking about are properties and methods of FireDAC. It'll look different, but I discuss the how and why of FireDAC in that. Question, does FireDAC have native drivers for .dbf files, or am I limited to using ODBC? You're using the ODBC bridging driver. There is no native drivers for the file-based database servers, because they don't have a native API like the DLLs that are available for Interbase or any of the other servers. Is there a recommended way to migrate from ADO to FireDAC or a tool for it? No, there is not. There's some similarities, but that's going to be a manual transition, and it's going to be worthwhile, especially if you're using ADO to talk to a database server in which there's a native driver for it, like MS SQL Server or something like that. Someone says, I have a problem dealing with lookup columns, especially when I need to create it at runtime. Well, the applications I work with, in fact, I'm working on a major application right now, and we're creating lookup columns at runtime, and we're not having any troubles with FireDAC at all. How can FireDAC make this feature more useful? Well, it doesn't. It's using the TDataSet API, so I don't have anything more about that. I do have I have an example of a lookup data or a lookup table, actually it's a lookup field in my book on virtual fields, but it's not, it's only like a couple pages long, that discussion. I don't have anything more to add to that. Has the book been updated to cover any important new things in FireDAC in the last 2 years? Since I use all my examples in Interbase, the answer is no, and the answer also includes that there's not been major updates other than major updates to FireDAC. So basically the book is as current now pretty much as when it did ship. Now there have been some there's been some bug fixes, and there's been some things that I have fixed in the book, because I have made some minor changes to it, but I've tried to update that information to the errata page associated with the book, where I point out, okay, this thing is I got this wrong, and I have one particular thing that I can't remember what the feature was, but I said this doesn't seem to work, and later discovered that it was my misunderstanding and not a problem in FireDAC. I believe I posted to the errata page to actually clarify that. Is it possible to add UDF functions for expression indexes? I don't think so. Unless if you're talking about user-defined functions in your client, then the answer is yes, and I've never done that. It's such an interesting idea, and I believe that Dimitri has, in conversations I had with him, he said there is an example somewhere. I don't have the answer to this, but there's an example somewhere where he showed how to use the API to create your own FireDAC SQL scalar functions. Darn, that's a super advanced feature. I've not tried it, so I don't have any more information. Maybe I'm wrong, but I do believe, when I think back to it, there's a way to do it, but I just don't have that. Let's see, is the connection the only component that needed to be included in each thread, or must all components on the lower level also be included, like the table? Well, since your table has to hook up to the FD connection within the thread, I'd create those in the thread. I can't see any other way that it would be viable to do that. If you have multiple threads and there's a shared TFD table or a TFD query out there, what's to prevent the two threads from trying to use that at the same time? And then you're going to get a conflict and problems. Go ahead, instantiate the FD connection, possibly used in conjunction with the thread pool, which is a driver setting, by the way. You may want to use a named driver because it allows you to reuse the named driver configuration across multiple threads, and you don't have to configure each one up individually. And I look at the help or my book about named FireDAC drivers. They're actually like aliases. And yeah, go ahead and make your FD queries and FD tables, instantiate them within the thread, either at the initiation of the thread. Okay. There might be even situations where you would want to have a new FD query created for each. If you have a loop within the execute method of the thread, there might even be situations where you want to create a new FD query or FD table on each iteration of that loop. I can't think of why, but that might be a possibility. Okay, cache queries and the ability to alter the results. I'm curious as to where the cached updates stored. The cached updates stored. Okay, so I'm just going to answer a higher level question. This one pertains to cached updates and the ability to alter results, even undo. Where is the cached data stored? Cached data is stored in an in-memory structure that represents what can be persisted for the data set, unless you're using centralized updates, in which case it's the FD schema table adapter that stores the trace. And what that information consists of is the structure of the table, the actual data of the table, individual changes being made to the table, and in the case of the FD schema adapter, the order in which the changes are made. And if you call save to file or save to stream, you have the option of saving all of that or just some of it. And when you do a load from file or load from stream, what you've saved is restored into whatever type of data set you're loading that data into. Cached updates and everything that surrounds it are so powerful. Let's see, it says FireDAC is great, but in local network, I think there's too much latency due to many send receive message. BDE instead copy table to local drive and sync only changes. I don't know that that's true about the BDE. The BDE was very, very heavyweight when it came to network traffic. Maybe you know something I don't, but I don't know about FireDAC. And part of the problem is when you're using FireDAC with local databases. Now you may be talking to an actual local server, but I can't really address that question because it doesn't seem that I don't see there's a problem there. Can FireDAC be used in parallel programming with TTask? We addressed that. I think you're better off using your own instantiated thread. TTask does it for you, but TTasks, I believe they're too transient to bother with something like that. Let's see, JSON files is sent in stream, avoiding the latency. Could we behave FireDAC in that manner? I don't know what the latency he's talking about, but you can take any FireDAC mem table, any FireDAC data set, and you can create a JSON stream from that using save to file. You just have to specify the file format. Let's see. Oh, someone said, never guide. The link is good. Okay. There's some code here. Create due time, synchronize, nil procedure begin, and start. I don't know. I don't want to mess with that code right now. Could FireDAC be used in parallel? Oh, there's the question again. Does FireDAC have native drivers for ODBC files? Did I click back some way? Either that or the question's being asked over again. My query is on a specific error FD client data set. Well, when using a client data set, we often get error record modified by another user or record not found. This is occurring when we modify the data in called apply updates. Maybe they're talking about FD mem table. Whenever you have that, the one problem is that you may not have the, somehow FireDAC may not be determining what the key fields are, and that can cause a failure when apply updates is called. Other than that, I don't have an answer to that question. I'm having a lot of no answers here. Questions about the parser, if query, oh, a question about, if all queries and stored procedures are created for MSN SQL, can we use it for MySQL? Probably not, because they're very different. The language for your stored procedures are typically different between database servers. I'm not familiar with the language in MySQL. And also, there are dialect differences in the execution of stored procedures. That could have a problem. Someone said, ask the question about using XML because I didn't see anything in the index of your book. Does it cover XML files as a database? No, it doesn't. So let me just answer that one and say no. I don't like the idea of using XML as a database anyway because it's not a database. It's a data store. When migrating from IBX to FireDAC, what components to replace TIB dataset with? Well, that'd be a that would be a T query or a T table, but the philosophy is different. You don't have a command text property. Instead, you have an SQL property, or you have the table name property. So it's a little more difficulty. Again, someone's asked about lookup tables. I have no problem creating lookup tables with FireDAC. So the questioner said they had some difficulty with T-client dataset. Well, maybe FD memtable will have that solution. And if you have FireDAC already installed, just try it. There's a lot of similarity between the FD memtable and the T-client dataset, except for the way that you get data into the FD memtable. Again, someone is asking about the FireDAC network latency, and he planned to fill a FD memtable at once and send back changes only. I haven't seen this approach in any webinar. Well, FireDAC, the only reason I would do something like that is if I was working with DataSnap and I wanted to, I would need to, I want to send a FD memtable with changes over to like a DataSnap server and have it apply it, and that certainly you can do that. You can do that. I don't know about this network latency. I normally if you're talking directly now, if this is a mobile app, that's a different situation. And in that case, taking the FireDAC memtable and streaming it back to the DataSnap server and have it apply the changes, I don't see any reason why that wouldn't work. Okay.
Would that also be a situation you want to use the cached update?
Yeah, cached update. Yeah, cached update on the mobile client, and then you send the whole data set back, including the cache, and that has all the information needed. Then you wire it up to an appropriate. Let me think about this. To wire it up to an appropriate. Actually, you would use a TFD table. Or TFD query and wire it up to the appropriate connection and call apply updates. I don't know why that wouldn't work. It's unusual. You have to play around a little with it, but certainly something like that works with the cache with a client data set. So I don't see why it wouldn't. All the data is there as long as you send the entire FD query back, and then so that has one of the issues is how big is your select? How many records do you have in memory? You got to be mindful of that, because that's going to be a bandwidth issue. Can we use a RADML with ADS, the Advantage Database Server? Yes, I have done it, but it's emulated. It doesn't add any performance, but it is convenient. Does FireDAC have native drivers for DBF? Nope, it's the ODBC driver. Is the save point still available after we close the application? Where is the save point stored? No, it's not stored. So here's the real. Let me rephrase the question. If I have a FD query and I have it in cached updates, and I'm going to persist that FD query and I store the value of save point at some point, I can persist that FD query, reload it later, that save point value should still be available. Now, I can't remember in FireDAC if we have, when we call, when we're in cached updates, if we still have the optional params property like client dataset. I don't recall seeing that. So I'm not sure you could store it right with the component itself, but you could persist that off in some location, and then I believe you'd be able to get back to it. Okay, let's see. What's the fastest way to locate a record in a very large data set? The fastest way is to create an index and then to use the find record or find key. Find key. That's the fastest way. It's extraordinarily fast. As long as you have created that client side index, you can use it to go directly to the record, and in 1 millisecond. My example that I show has 25,000 records in memory and an index, and find key takes 1 millisecond, which means that's and sometimes it's 0, so it's faster than that. And I've done this on extremely large data sets, but that assumes you have all that data in memory too. If you are actually, if you're paging data in and out, then the find key will work, but it may have to fetch some records first. But that's very interesting. FireDAC, can it use a file name to automatically save data to disk on every update? Well, every update, not every, and you know, client dataset doesn't do it on every update. It does. Client dataset has a file name property, and when you open the client dataset, it'll open that file. And when you close the form or you call save to file and don't specify a file name, it'll automatically save. FireDAC has that exact same thing. It's just under persistent file name under resource options, I'm pretty sure. Let me look. I've got a database right here. I'm going to come back and answer that question after Delphi loads. But it's called persistent file name, and then there's an auto load, I think, property. And basically, you could create an FDMEM table that when your application opens up the FDMEM table, it automatically loads from that file and automatically saves to that file. If you have cached updates on, it automatically saves that file with the change log intact. So yes, that capability is same capability as the file name property in a client dataset. That is available from a FireDAC dataset. Okay, here's someone asking about cached updates in an N-tier environment, and I cannot answer that question intelligently, but I know that the data snap capabilities and combined with the data snap or the capabilities of FireDAC, and I know that it is possible to work miracles with that, including in a data snap environment. I've looked through the capabilities and I know it can be done. I haven't had a need to do it, and so that's why I can't give a more intelligent answer to it other than yeah, go ahead, but you know, I can't tell you exactly how to do it because you're going to be learning it on your own. Is it possible to have a centralized cached updates in a client using JSON data and TFDMEM tables? In client server work modes works fine, but with JSON data, it's not straightforward. Well, here's the thing. Note that the FD schema table adapter has a save to file feature. So maybe you've kind of been trying it the wrong way. So really the question is saying, can I use FDMEM tables? And I think that we're asking about storing the data in JSON format and then restoring that data later, letting the user make changes and then storing the data and then retrieving that master detail relationship from a JSON file on disk or from a stream and so forth. The answer is look at the FD schema table adapter because it has a save to file and it can save to JSON and it can save to a stream in JSON or in XML. And so what you do is you load your initial data or have your data structures and your necessary, you know, how they relate to each other defined in FDMEM tables and have them all pointing to the FD schema adapter, schema table adapter. And when the session is done, do a save to file on the FD schema table adapter. When you're opening up the data again, have your FD schema table adapter and all your FDMEM tables with all their proper relationships there, and then load the FD schema table adapter. That should be able to do it. In FireDAC, is it possible to work with concomitant transactions? I mean, while committing one, we can roll back another like the BDE and DB Express. You can configure how your transactions are committed, whether they are what are the various settings on that? I'm trying to recall off the top of my head. There's basically 3 different transaction modes, and FireDAC supports the 3 different transaction modes, whether it first reads the records that you're committing to make sure that they're still there, or if it, good heavens, I apologize for that I am not thinking real clearly about what those modes are. Let me quickly bring up a connection component, and let's see. And this might be something in the TX options, which is a 5th. Isolation. So there's read committed, read, a dirty read. So when you're committing transactions under the TX options of a connection, and a FD transaction also has these options, you can set the isolation mode. And the isolation mode basically addresses issues about when you are committing a transaction that's been performed, whether it reads, it only works with the way it was when I believe the transaction started, or if it actually reads the current state of the records prior to performing its commit, so that it can then see the commissions of other transactions that have occurred prior to your call to commit. So take a look at the txoptions.isolation. And now while I'm in here, there is the, let's see, resource option. I'm going to find where this is. And the property is called persistent file name. And excuse me, there's, and backup is also really cool one. Let's see, and that's in resource options. How about in fetch options? That may be where it is. Oh darn! I don't see. Maybe it's just persistent is one of them. Oh, you know what? This is a. I realize what it is. This is not an option. I was looking at the connection. This is definitely an option in the TDatasets. So under resource options, it's called persistent file name and persistent. Then there's a backup option, and then if you go to the connection under resource options, you have a backup extension, a backup folder, and a backup option. And what that means is you can have a file automatically loaded when it opens, automatically saved when it closes or is destroyed, and it can keep a backup of the last changes, so that when you open it up and make a change and close it, it closes the file, but it makes a backup. And you can actually have, I think, multiple backup versions as well. It's really awfully cool. Okay, let me go back to the questions. We're getting to the end here. For those of you who've stuck with us all along, it's you're to be congratulated. You have a lot of patience. What did you use to migrate from TADS query to FD stuff? Well, we did not use refind, we just search and replace. We also had very supportable mechanisms in that we had used data modules intelligently. In some cases, we had our TADS data sets created on the fly, and we just switched that over to creating FD data sets or TFD queries or whatever. So basically, our architecture gave us that really nice, easy migration path. Does the purchase of the book include a PDF? No, it does not. I apologize, but they're coming from 2 different sources. I wish we had a bundle that we could do, but we don't. Oh, here's an interesting. Here's a really good question. The latency that Juan was talking about had said, if you have master detail and you're browsing to many different tables, the navigation back and forth is very slow. Aha! I will credit this where credit is due, but one of our technical reviewers, Jens Fudge, had a solution for this, and that is there is a, let me see if it's in the fetch options. Okay, fetch options detail delay. And he pointed out he likes to set detail delay to like 30 or 50 milliseconds. And what that means is detail records will not be fetched until you've sat on a record for like 50 seconds or 40 milliseconds, I'm sorry, 40 milliseconds or so. And that allows a user to browse to the master table and, you know, go down, 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 down. And it's not until they stop on a record that FireDAC will actually go get the detail records. And so there's a configuration property for that. So very good question. And Jens, thanks for the answer. Can FireDAC deal with RavenDB? I don't know. If there's an ODBC driver, then yes. Okay, David Intersaponi added that cached updates works in RAD server multi-tier, just as it does in client server architecture. Call apply updates from the client connected to the RAD server package and using FireDAC data access components. Thanks, David. That's wonderful. Well, I see we're at the end, and I know, like I said, you're all heroes who stayed to the very end of this. But it's been a lot of fun, and I've really enjoyed sharing information about FireDAC with you. We're going to sign off now, and you can look for the replay of this webinar coming up. And Jim, thank you for the opportunity to do this today.
Oh, absolutely. Thank you for your time and putting this all together and sharing your vast knowledge with everybody.
I am certainly pleased to do so.
I love this because even though FireDAC, I feel like I know a lot about FireDAC, but every time I get a chance to hear you talk about it, I learn so much more. So thank you for that.
You're certainly welcome.
All right, well, take care, everybody, and we'll see you next time.
Bye now.
Bye.